Let's take a look at powers of complex numbers in trigonometric form. Now, you may remember, in fact, hopefully you do, there's a previous video if you don't. Trigonometric form of a complex number says look at the magnitude of that complex number times cosine theta, that's the real part, plus I sine theta, where theta is the angle formed between the line connecting the origin and the point in the positive x-axis. And this, we usually use the shorthand RCIS, cosine I sine theta for. So that's the magnitude, that's the angle for the complex number. Remember that the way that you multiply two of these numbers is, say, RCIS theta plus some other magnitude, CIS, some other angle, is R times the other magnitude, CIS theta, plus the other angle. Well, what happens if this is R CIS theta again? In other words, that's R CIS theta squared. Well, this is R times R, and this is theta plus theta. So see that squaring R CIS theta gives us R squared CIS, not theta squared, but 2 theta. Okay? You could repeat this process indefinitely, and you would get the net effect R CIS theta raised to any positive integer power n equals R to the n CIS n theta. Okay, so that's the rule we'll be working with here. Okay, and perhaps we ought to do a few examples. How about 2 CIS 10 degrees to the fourth? Well, that's just 2 to the fourth CIS 4 times 10, which is 16 CIS 40 degrees, somewhere in the first quadrant, and a magnitude of 16. We could also do, say, fractional magnitudes, CIS, or something outside the first quadrant. You could do negative, whatever, 185. There's something in the third quadrant to the third. That raised to the third is 1/8 CIS. Multiplying this by 3, we get 555. It's perfectly acceptable to leave it like that. That would get you to the right point. Or if you want to subtract multiples of 360, this is exactly the same as 1/8 CIS 195. And here it's easier to see that you end up in the third quadrant.